All right, hi everybody, Mrs. Pesic here. I am live with Block 2. Block 2, you want to give a little shout out to Block 7 and 8? All right, so we are looking at section 1.6, which is called Library of Parent Functions. Your learning objectives are to identify and graph linear and squaring functions, cubic functions, square root functions, reciprocal functions, and also identify and graph step functions and other piecewise functions, and to recognize graphs of parent functions. So my goal for you in this section, one of my goals, is for you to have instant recognition of these parent functions. So if I ask you to graph, f of x equaling x squared, I would expect all of you to be able to say, all right, trace it in the air. What's x squared look like? And you're all tracing a parabola, okay? And if I ask you to graph f of x equaling square root of x, can you trace that one in the air? All right, some people have it. That's the one that's going to start at 0, 0 and go out to the right. That one looks like this. People at home can't see my hand. It looks like this. This is the square root of x graph, right? That's that one, and so on. So I have this gift for you, all right? If it sounds better than worksheet. So you have this gift, and we're not going to work on this completely. That's going to be part of your homework is to finish it, but let's take a look at a few things on the gift. So for example, you have a linear function. I'm going to come back to this page. Linear function is f of x equaling ax plus b. All right, this is a linear function. And you're going to fill out all sorts of information about that. What would be the slope of this function? I'm getting my popsicle sticks ready. The slope of that function is going to be what, Allie? A is the slope.
Yeah.
Slope is A, and the domain for this function would be what, Dane? I think it's okay to plug in 0 into a linear function. Like here's an example of a linear function, right? So, Grace?
Would it be all real numbers?
Yeah, let's say all real numbers. So the domain is going to be, from negative infinity to positive infinity, right? All real numbers. How about the range? How far down does the graph go? How far up does the graph go? Rachel?
Negative infinity to b.
Well, I think it can go higher than b, can't it? I mean, it can go high. B is our y-intercept, right? But the graph goes higher than that. So negative infinity to
Positive infinity.
Positive infinity, all right. And what would be the x-intercept? And what would be the y-intercept? You take your pick on that one. Which one do you want to tell us about, Dylan?
The y-intercept is b.
All right, you took the easy one there, Dylan. Y-intercept is b. How would we go about finding the x-intercept? Rebecca?
You would plug in.
Plug in what for what? In our equation, which is right here, to find the x-intercept, plug in what for what? What do you think, Jack?
0 for y.
0 for y. Do people agree with that?
No.
I do.
If we want to find the x-intercept, we're going to plug in 0 for y. If we want to find the y-intercept, we would plug in 0 for x, right? So we're going to plug in 0 for y. That means this is our y. So I get 0 equals ax plus b. And then we're going to solve here by solving for x. So talk me through that, Nick.
You divide by a, or no, subtract b.
Subtracting b first. We get negative b equals a times x.
Then divide by a.
Then dividing by a, we get negative b over a. That's going to be our x-intercept. Are we okay with this?
Yes.
All right, and next it's asking increasing, decreasing, or constant. What do you want to tell me about that, Julia? Okay, and how would you know? By looking at your function, whether it was going to be increasing or decreasing or constant. The slope. So we look at the A. So for that one, let's say it's going to be increasing if the A is greater than 0. It's going to be decreasing if A is less than 0. And really, if A is equal to 0, then it's going to be what? Constant. But guess what? What's our next function called?
Constant.
Constant function, right? So let's move on. We'll do that one, and then I'm going to leave the rest for you to do as part of your homework. So let's do the constant function, then we're moving on. Whoopsie. So constant function is just f of x equaling some constant c. What's the domain for this? Well, first of all, what's the graph look like for a constant function? All right. Memo to block 7 and 8. Block 2 is all doing kind of weird things with their hands, like going like straight across. So like something like this?
Yeah.
All right, so let's get that. All right, so something like this. All right, so if this is our constant function, you can sketch a little graph of that. Doesn't matter where. Then our domain is going to be what for this graph? Domain is going to be what here, Justin?
All real numbers.
All real numbers. So we can say negative infinity to positive infinity. What's the range for this parent function? Jack?
That also all real numbers.
How far down does this graph go? How far up does it go?
All the way.
I don't see anything down here.
Oh,
I don't see anything up here.
so 0.
Well, it could be. Could be down here.
So it's C, right?
Great. Okay.
Is it just like 0 to 7?
Well, if this is C right here, do I have values all through here? What's it going to be? Just C. So our range is just C. And I don't know how you want to write that. You could just write it like the Y values have to equal C. All right, you could write it that way, or in interval notation, I guess we could say, I want to go from C to C. I don't really like that method. Let's just say Y equals C. And then the graph is a, what kind of line? Avery?
Horizontal.
Horizontal, thank you. The slope would be what, Garrett?
The what? Sorry, I was admiring.
Garrett, stop admiring. Focus. The slope is what?
The slope is wouldn't it be? Wait a minute.
Garrett, is our line rising or falling or staying
Our
constant?
line is staying constant.
So what's the slope
So
of
the
a horizontal?
slope is 0.
0 it is. All right, slope is 0. What about the intercepts, Jimmy? What do you want to tell me about the intercepts?
Y equals C.
The y-intercept, all right, let's go with that. So the y-intercept is equal to c. Everybody agree that's where it's crossing through? Right? And what about the x-intercepts? Yeah, I would say no x-intercepts unless what?
C is
That's on the
C is on the x-axis.
Unless c is 0 itself, in which case every real number would be an x-intercept. Does that make sense?
Yeah.
So no x-intercepts unless c equals 0, and then everything would be an x-intercept. All right, increasing, decreasing, constant, Ryan?
It is constant.
It is constant over its entire domain. All right, do you get the idea of how you're going to fill this out?
Yes,
The
ma'am.
pages in the book will help you with this as you are going through, but you're also going to learn about identity function, which is just f of x equals x, the square root function, you got the squaring function, which is f of x equaling x squared, the cubic function, and the reciprocal function. And we will compare notes on these, not next class because you're taking the test, but for block 7 and 8, next class, we'll be comparing notes on this. All right? At this point, we're going to look at a few other things from this section 1.6, but just know that this is part of your homework.
Are there going to be like examples of these in the book that we can compare
Yes,
to?
there are lots of examples, and all the information is there for you. Okay, so, see, I got to back up. Okay, so, back up even further. Forward. All right, so let's talk about step functions. All right, for your notes, step functions are graphs that look like stair steps. They are piecewise functions that just have little horizontal pieces to them. And let's see how this is going to look. So in this particular graph, f of x equals 2 if x is between 0 and 5. It's equal to 4 if x is greater than 5 but less than or equal to 10. And it's equal to 6 if x is greater than 10. So let's go ahead and sketch this graph. And how are we going to do that? We're graphing it. The first line, f of x equals 2, I'm just going to graph the line y equals 2. All right? So I want that line, by the way, is that a horizontal line or a vertical line, Grace K? Vertical line. So if I make a table of values, and I fill in 2's for all the y's, and I pick whatever x values I want, like 0, 2, and 4, and I plot these 0, 2, 2, 2, 4, 2. What kind of arrangement am I getting, Grace? All right. It's a horizontal line. I always forget 2, and that's why I got to make a table, right? All right. And so if I get this horizontal line, but I don't want the whole line, do I? I only want this graph between 0 and 5. So I'm going to erase. Oh, do you have a piece of graph paper out? Oh, block 7, block 8, find piece of graph paper. You need to do this on graph paper. All right, everybody's finding graph paper. You're graphing this with me. So I don't want to graph the whole thing. I only want this line graphed between 0 and 5. All right. Okay, so we understand we want a little horizontal segment, and we want it to be a height of 2, and we want it to go from 0 to 5. However, I see that it's 0 less than x, and x is less than or equal to 5. That means I do want to include this point right here, which is 5, 2. I do want that ordered pair. But at 0, I don't want it to go all the way to 0. So that means I have to put a hole in the graph at the ordered pair 0, 2. The hole in the graph means I want to go all the way up to that point, but not including that point. Are we okay with this?
Yes, ma'am.
All right. Then next one that we're going to graph is y equals 4. So describe what I should be drawing on my graph. Grace J. So I want a horizontal line at y equals 4, like this. So I don't want all this. I only want it from 5 to what? And you're saying I want an open circle? Open circle at 5. Open circle at 5 and a closed circle at 10. So something like this. Do people agree with this? All good? And then now we're graphing our last piece, which is y equals 6. Yes.
Do you have to put every dot on the line? Like, do you have to, like, for y equals 4, you just have the straight line?
I just need that horizontal segment drawn in. Yes, I have to have that horizontal segment drawn in, and I need a hole at 5, 4 and a point at 10, 4. What about this next part? Y equals 6. Y equals 6. Describe how I should draw that, Hannah. What kind of line is y equals 6? Horizontal, vertical? Vertical line. So we're going to make a little table, x, y. We're going to put some 6's in for y's, and we're going to pick some various x's and 0. You're changing your mind? Yeah. All right, so I want like 0, 6, 1, 6, 2, 6. All right, so that's okay. We're going to remember this one, right? We're going to remember y equals a number is always a horizontal line, right? But we don't want the whole line. Hannah, how much of this line do we want?
Only x is greater than 1.
All right, so I should erase everything up to 10.
Yeah.
And do I want a point at 10 or a hole in the graph? Hole in the graph right here at 10, and then graph going to the right. As a matter of fact, I can do better than that. So hole in the graph at the ordered pair 10, 6, and the graph continues on to the right. Are we okay with this? Awesome. Let's take a look at That's a, oh, why is it called a step function? You see how it looks like stair steps? Looks like stairs. Okay, let's take a look at the most famous step function. The most famous step function is called the greatest integer function. And it's got a special symbol, all right? Greatest integer, it's got the double brackets around the x. All right, the greatest integer function works like this. Whatever number you put in for x, you're going to want the output to be the greatest integer that's less than or equal to x. All right, so let's just practice a few. So if I ask you what is the greatest integer less than or equal to 7.3, you're going to tell me what, Rachel? I'm looking for the greatest integer that's less than or equal to 7.3.
Would be 7.
Would it be 7?
Yeah.
Yes, 7 is the biggest integer that's less than or equal to 7.3. What would be the greatest integer less than or equal to 8?
8. Oh, sorry, I didn't even get the point.
8,
My God.
right?
Yeah.
Right, because it is less than, 8 is less than or equal to 8, right? You get the idea? What about this one? What's the greatest integer less than or equal to negative 3.5, Dylan?
-4.
Dylan says negative 4, do you agree?
I do, but.
Yeah, because on our number, picture a number line, here's negative 3, here's negative 4, here's negative 3.5, but we want the greatest integer that's less than or equal to negative 3.5, so that would be negative 4, right? I got to go to the left of the number. All right? Okay. What's greatest integer less than or equal to 2.1? 2. What's the greatest integer less than or equal to 3? 3. And so what's our domain here for this? Domain for this function is what, Garrett?
Domain?
Yeah, that means like what numbers can I plug into the function?
Yeah. So, when,
Also, x minus 4.
yeah, let me go over this again. So, yeah, alright. So, you would be able to,
Am I allowed to plug in any number I want?
yeah,
So what do we say the domain is then?
so, all real numbers.
All real numbers. So our domain is going to be
I don't know.
negative infinity to positive infinity. What's our range? What are all the possible outcomes for this function, Allie?
Negative infinity to positive infinity?
So we can get like negative 5.4 out of this function, or 3.9 out of this function.
All integers?
Integers. All right, so the range is the set of all integers. Set of all integers. All right.
This question, why is it all integers and not all real numbers?
Well, because on all of these outputs, what did we get out of all of these? We only got integers out, right? We were not getting all real numbers, because real numbers would include the decimals and so forth, right? Rachel?
So the range is the outcome, and the domain is.
The domain is your set of all your inputs, so we can put any number we want into this function.
The 2 brackets and then the x, that would be like x.
So
would
the
be
x is
domain.
the input,
Okay.
and the output is whatever you get out of the function. So this is whatever is the greatest integer less than or equal to these. All right, so what about, what else are we asked here? What are the intercepts? I kind of like the way the book answers this question. Let's take a look at page 69 in your book. It says the graph of the greatest integer function has the following characteristics, as shown in figure 1.72. They got a nice graph there for you on page 69. It says the domain of the function is the set of all real numbers. The range of the function is the set of all integers. The graph has a y-intercept at 0, 0, and an x-intercept in the interval, and x-intercepts are every number in the interval from 0 to 1, including 0, but not including 1. All right, the graph is constant between each pair of consecutive integers, and the graph does jump vertically 1 unit at each integer value. So if you graph this on your calculator, because you can graph these, whoops, graphing on your calculator. Trying this again, documents. Okay, so if I go to a graphs page and I type in INT, INT is your abbreviation for greatest integer function. So if I say I want the greatest integer function graphed, I just do INT and there's my graph. And if I just change my, if I just change, yes, I'm just, that's kind of interesting. I'll leave it like that. If we can see this still, right? So I kind of zoomed in, and what I should see here is, I'll just do that, is like this. But when I get to 1, which is right here, I have a hole in the graph. And then it jumps up here and goes over to 2, which must be right here. Does that make sense? Avery?
What is typing?
INT, and then parentheses X. This is the greatest integer function. All right, so I guess my point is, do you see how if I take any number between 0 and 1, and I plug it in here, like 0.75, what's the greatest integer less than or equal to 0.75? I hear 1, I hear 0. 0, right? So 0.75 goes to 0, that might be right here. So that would be an x-intercept, correct? Because it's on my x-axis. So what your book is saying is that the graph has a y-intercept right here at 0, 0, and the x-intercepts are all of these points from 0 to 1, not including the 1. Does that make sense? Okay? All right, questions about this one?
Why do you include the 2
Oh, was that supposed to be hole in graph? My bad. So this was supposed to be up to here. Spencer?
I do my phone.
Okay. Are we okay with this? All right. Okay. So that is that part. What else? So we're here. We talked about increasing, decreasing, constant. Okay. And I don't want to do this one for you. You got some homework problems similar to this. But for example, if this is the function that you're given, h of x equals 4 times greatest integer less than or equal to x minus 3, and then a plus 2 on the outside, you would take this in pieces. You're going to plug in 3.8 wherever you see an x. So I want 4 times greatest integer less than or equal to 3.8 minus 3, and then I'm going to add 2 on. So what's 3.8 minus 3? And what's the greatest integer that's less than or equal to 0.8? So I get 4 times 0 plus 2. Does that make sense? And so I end up getting 0 plus 2. I get 2. So my answer for h of 3.8 is equal to 2. Avery.
What are the intercepts?
The intercepts. Yeah, I was just reading out of the book. The intercepts are the y-intercept. Y-intercept is 0, and the x-intercepts are all of the numbers from 0 to 1. Not including the 1, but including the 0. All right? And it's constant, as it says, it's constant between, I'll say between integers. It's constant, right, on each little piece of its function. Okay, so we're looking at how to evaluate function. All right, let's see how much of this graph we can do before you guys need to leave. So we are graphing this piecewise function. You have your graph paper. You are ready to graph. We have 3 separate pieces to graph. All right? So we want to graph f of x equaling 2x plus 4, but only for x less than negative 2. We want to graph 3, but only for x between negative 2 and 1, including the negative 2, not including the 1. And we want to graph negative 3x plus 8, but only if x is greater than or equal to 1. All right, so in this case, let's graph y equals 2x plus 4 first. That's the first piece. And I know that my y-intercept is 4. 1, 2, 3, 4. By the way, it's never been more important to graph in pencil because you're going to keep part of your line and you're going to erase part of your line, right? So you're graphing in pencil on graph paper. So my y-intercept is 4 and my slope is 2. So I want to go up 2 to the right 1, up 2 to the right 1, down 2 to the left 1, down 2 to the left 1. Everybody agree?
Yes.
So here's my line looks like this, but I don't want to keep the entire line. I only want to keep what?
X is less than.
I want to keep the part for x values less than -2. So that's when you got to look on your x-axis, find -2 on your x-axis, and we want to keep everything that is less than, we want to keep all of the points that I plotted if the x-coordinate is less than -2, which means I want to erase all of this.
Wait a minute, isn't X greater than? Wait.
I want to graph,
Oh, yeah, because we're looking at, sorry, I was looking at one.
right?
Yeah.
So, and at the ordered pair, well, when I plug in -2, I would get f of -2. No, if I was going to plug in -2 here, I get 2 times -2 plus 4. Does that give me 0? So do I want a point at -2, 0, or a hole in the graph? I need a hole in the graph there. So let's just be careful to draw that in. So I should have a hole in the graph at the order pair -2, 0. Rachel.
So you just want plug in for x all values less than negative, or yeah, less than
Yes,
negative.
less than -2. But we actually do need to plug in -2 to see where the hole is going to be. All right, let's go on to the next piece. And the next graph is y equals just 3. What kind of line is y equals 3, Grace J?
A horizontal line.
Horizontal line. And it's up here at a height of 3, right? And so how much of this do we want to keep? What should I erase here, Julia?
Since it is less greater than or equal to -2, you would include the -2,
Okay?
and it's less than 1, so you would do it on the graph and that's x equals 1.
All right, so you're saying you want a point at -2, but a hole in the graph at 1.
Yeah.
So I should have a point at -2, 3, and a hole at 1, 3. Do we agree with this?
Yes.
All right, and our last piece is graphing y equals -3x plus 8. So for this one, I need my y-intercept at 8, and I need a slope of -3, so I got to go down 3 to the right 1, down 3 to the right 1, and up 3. I'm a little bit off my graph to the left 1. And I could draw that in, but before I draw it in, I want to know what part am I keeping, what part am I erasing, Rebecca?
What would I do with this greater than 1?
I want to keep everything greater than 1. Well, here's my 1 right there, right? This is order pair 1, 5. Does that look right?
Yes.
So I think the graph starts here and goes this direction. Down, is it down 3?
Yes.
Like this. I'm drawing a few more points to plot. My mind's looking a little bit crooked. And did I want a hole in the graph
Yeah,
at
no.
1, 5, or a
No.
point?
Point.
Point. Does this look okay?
Yes.
But I need to erase that and that. Does this look okay?
Yes, it does.
All right, here's my big question for you. Does this graph pass, does this graph pass the vertical line test?
Yeah.
Yeah, because even right here,
Good morning, at this
it
time,
goes
we have
through
the
a
sophomore
point and a
class.
hole, and the hole doesn't
Please
count
go
as
to
point,
the line
right?
section
So
now.
it's all good, it is a function. Pardon me?
Why did you start at 5 on the?
Because if I plug in 1 into this function right here, because I want to start at 1, that's -3 times 1 plus 8 is 5. So I know that's where it starts at 1. I could draw in the whole line and erase that part. This is what the graph looks like. All right, you're going to check Blackboard for homework, but the homework for this section will not be due until Tuesday, right, for you guys? All right, and block 7 and 8, thank you for watching, but this homework for you is due next class. All right? Okay.
Do we leave our stuff?
Yeah, that's okay.
Yeah, you can, You can leave your stuff here. That's fine. All right.
And you go back. And you open it.